Cool. Yeah, so GM everyone. Then I get going, right, Rebecca? Right?
Yeah, let's get going.
Okay. Cool. Yeah, hi everyone. My name is Evgeni. I am a developer relations engineer at Wormhole. And today I'm excited to talk with you about interoperability and then afterwards demonstrate how straightforward it is to deploy a token that lives simultaneously on multiple blockchain networks. Right. So before doing that, let me first check one more time if I see the chat. Okay, I can see the chat here later. That's cool. Just for questions. All right. So before diving deep into native token transfers and how to create a token, I want to start off and actually look in general at what the state of interoperability is. But in order to do that, we need to clarify what interoperability actually means, right? So in order to do this, let's look at the number of active blockchains. In this chart, we see that the number, so the count of active blockchains is going up with every year. So this graphic is from around 23, and then we already could see that the number of active blockchains is over 100. Probably nowadays it's about at a number of like 200 blockchains. So the number keeps going up and up. What we see here is a screenshot from Wormhole Scan, which shows that not only the number of active blockchains is going up, but also the usage keeps getting fragmented across different networks. It's not like only we have new blockchain networks, but also users are moving between those. On this screenshot, we can see that, for example, from Ethereum, in the last 7 days, we had 38%. The 38% is actually the total volume of moved value through Wormhole, which left Ethereum and went to a number of different chains. We see Solana, Arbitrum, Sui, Base, and so on. So there's a lot of different chains and a lot of different users on those chains. Developers build on different chains, and fragmentation is an issue which we will try to solve with today, or at least do a step in the direction to make it easier to build applications or specifically tokens across multiple blockchain networks. Which brings me to the initial question, which says to explain what actually blockchain interoperability is. And so blockchain interoperability is basically enabling isolated blockchain networks to communicate data. So we've seen that we have a lot of blockchains, we have a lot of users and tokens across blockchains. So we need to find a way, or we want to find a way to communicate data or transfer tokens between those networks, to enable users to just use them in a more easy way. And the native token transfers framework that we are going to look at today together is one step in order to do that. These are some of the highest priority considerations for interoperability. On this slide, we can see 5 that we took into account when building such a framework. 1 is security. 2 is decentralization. We want to ensure that the token transfers or data transfers in general are not going through a centralized party. We want to make it as scalable as possible, and at the same time have the best user experience. So these are kind of the challenges that we are facing in order to create a framework which will make it as easy as possible, as I said. All the Wormhole code is 100% open source and verifiable, and we try to combine all of those considerations in this framework together. Let's look at the cost for interoperability before looking at some of the solutions. What are the costs of interoperability today? And most of them are actually due to wrappers. So a wrapper is a smart contract or a program which in the past would own the token on the respective chain. So let's say you would want to send USDC from Solana to BSC, then the program on BSC would have full control over the token. So you as a builder would lose ownership over the token if you would use wrappers beforehand, which would lead to those things mentioned on the slide, which is terrible UX because you have a lot of wrap tokens where it is unclear what the canonical token is. So they would not be also composable, meaning that it will be hard to use wrap tokens in DeFi applications like lending or lend or borrow applications because of, for example, not enough liquidity, and the asset would be very fragmented. So again, it's very hard for a user that comes into a new chain to understand what is actually the canonical asset that I can use that has enough liquidity and that I can use in different protocols with ease, which would exactly lead us to a situation like that where it's not clear, okay, which is actually the right USDC or the canonical USDC that I would want to use in my application. Which brings me to the topic of today, which is native token transfers. How can we kind of mitigate all the mentioned difficulties and make any token natively multi-chain and not controlled by centralized wrappers, by still keeping in mind our considerations that we had to be scalable, decentralized, and actually not lose user experience for the developer, but also for the user itself. All right, so how to actually do that? Let's look at how to deploy a natively multi-chain token. But before we do that, let's define what a native multi-chain token actually is. A token can be native across multiple chains without centralizing wrappers. This is an example of Wormhole Connect, of a UI that we are going to build together today, which basically shows, which shows that the W token can be native on Solana, Base, and other chains at the same time, meaning that it's not controlled by any sort of wrappers. It's natively deployed by the builder, and it still can be transferred from one chain to the other chain with a similar experience like transferring within a chain. So it doesn't need to be wrapped, and it's fully liquid on multiple chains at the same time. So how to deploy actually a multi-chain token with customizable security models is the next question, because we considered that we now understand what a multi-chain token is, and we understand that it can be liquid on multiple chains, but how can we make it secure at the same time and customizable is what we're going to look at next. Let me actually pause and look at the chat because I see that there is questions. So interoperability is about being able to communicate across blockchain. Is this like bridging a token? Oh, okay. Urban already replied to it. Cool. Then I'm going to continue with the workshop. Thank you, Urban. Just wanted to check. All right. So let's continue with the next slide, where we are about to discuss.
Hi, Evgeni. Sorry, I've been struggling to get on the stage, but I've been trying to join for a sec. There's actually a question in the questions tab. If you go back onto next to the chat, there's a questions tab. Yeah. In the bottom right.
Questions. Okay. Despite having native tokens and being deployed on different blockchain, is it still required liquidity to be added to every liquidity pool for it to trade? That's a great question. Thanks, Rebecca, for pointing me to that. You don't need any liquidity pools in order to use native blockchain, in order to use our entity framework. And how it works is what I'm going to explain in a second in the next slide. But yeah, so let me if it's okay, I'm going to continue with the slides and hope to answer your question with the next slides. If not, please let me know and we get back to it. And I'm happy to share more details. All right, so this customizable security models is what's going to explain or help us understand how to actually, or why we don't need any liquidity pools for the transfers themselves. So what's the customizable security model? Let's finally deep dive into the native token transfers framework. So these are the three things that our proposed native token transfers framework is enabling developers to preserve without while keeping in mind the considerations from before. So what's Entity? Entity is an open framework for seamlessly taking your token multi-chain. It's what we are talking about this whole time. While before the token ownership would be transferred to the from the deployer to the wrapper of the contract, with Entity, the builder preserves full ownership. So you can still customize the metadata of your token. You can do with it whatever you want because you still own it. It's fully upgradable. So it's up to the user to decide how you want to upgrade your token, what you want to do with the deployment. You don't need to use any centralized wrappers again. So it's fully up to you, and it's fully customizable because, as I said, you as a developer are the one that's going to actually have full control over the token and can do with whatever you want. And this is the part which is going to hopefully explain why you don't need any liquidity pools, which is these two different modes. So these two modes are kind of our, I want to mention that you are not limited to those two modes that we see here, but these are just the two that we see the most used by integrators in the past. So I would want to explain those two ways of how to structure or how to use the entity framework today to make it clearer why, for example, liquidity pools are not needed. So the first one is the burn and mint mechanism. The burn and mint mechanism takes your token and burns it on the source chain and then mints it on the destination chain. Let's go through an easy example of transferring a token called Encode, the Encode token from Solana to Ethereum. We're actually going to do that later. But to explain the burn and mint mechanism is, let's imagine you have the Encode token on Solana. You want to send it to Base, let's say. Then the token gets burned on Solana and minted on Base. Because it's a one-to-one relationship of being burned and then minted before, so it's sequential, so it happens after each other. No liquidity pools are needed at all because the token just gets created after the transfer itself. So after after enough of our guardians, which are our verifiers in the Wormhole network, say that the token was burned, then only the minting will happen. So this is the model number one, which we see used a lot, which we see being used a lot by integrators. And the second one is the hub and spoke model. So for the hub and spoke model, sometimes maybe let's imagine a scenario where you have an existing token and this existing token does not support a burn and mint mechanism. So in order to use the burn and mint function, your token obviously needs to have a burn function and the mint function, because otherwise, how can it be burnable or mintable? So let's say you have an existing token of your product and you just want to take it multi-chain without using wrappers. What you can do is use the hub and spoke model, where your token gets locked in a custody contract, which is controlled by you, when being transferred from the source chain, and then again either minted or then burned on the destination chain. If we go through the flow of the previously mentioned example, let's say you have an Encode entity token on Solana, and this token does not have a burn and mint function, and you don't want to upgrade that token because it's not upgradable anymore, for example. What you can do is then use the hub and spoke model to use Solana as your hub chain, and then use any number of spoke chains that you want. So let's say you have Solana as a hub chain with a non-upgradable entity token, and then Base and Sui as your spoke chain, where you deploy your token to like afterwards, and then when you transfer again your Encode entity token from Solana to Sui or Base, the token gets locked in a custody contract, like I mentioned, that you have full control over, not Wormhole, but you yourself. And then it gets minted on Base or Sui, and on the way back, it would get burned there and then unlocked from your program, from your custody account. And that's it. So again, you have full control over the token. You can customize it as much as you want, and still kind of be flexible enough to choose any sort of mode. You can also do lock and lock if you want. The entity framework does not limit you to any sort of unique customizations. These are just the two that we see being used the most. That's why I wanted to stress them. Right, let me look at the chat really quickly. There is no questions in the questions tab. So I continue for now. Let me know if that answered your questions about why a liquidity pool is not needed. Otherwise, I'm happy to explain it in a different way. All right, so now after looking at the two different modes, let's actually talk about security. Why is the entity framework, or why are some considerations of the entity framework that we did specifically to increase the security of specific token transfers? The first one is on-chain rate limiting. For every chain, the developer can specify outbound and inbound limits. So what does it mean? Let's say you want to have a mechanism of directing only a specific number of your tokens to a specific chain. So you have your token deployed on, again, Solana, Sui, and Base, but you want to have movements between Solana and Sui freely, and to Base only, let's say, 1,000 tokens on a 24-hour basis. And afterwards, you will stop it, and then you have a queuing mechanism to free up the tokens after the threshold timeframe is kind of reached. So this is something that you get out of the box enforced on contract level with entity. You can specify any inbound limits, outbound limits. It's all up to you. If you don't care, you don't need to use it. This is optional, but it's kind of a security mechanism to ensure that token movements between chains are actually controlled by the developer. The second thing that we that Wormhole core contributors actually implemented is what we call the global accountant. This global accountant upholds multi-chain token balance invariance. What it means is that independent of any used product of Wormhole, so it could be entity, it could be token bridge, it can be any other product, the global accountant is kind of an overview over any token movements between Wormhole connected chain. So this way you can ensure that you cannot transfer more tokens out of an ecosystem than the amount that's being transferred in. So not only for your token, but on a global scale, the global accountant checks which tokens are moving from one chain to the other. And if there is some sort of inconsistencies, then the global accountant could, in theory, interfere and double check a transaction to see if a chain is hacked and some sort of way more tokens are minted than should be, for example. Right. Let's look at questions really quickly. What happens to the original token if the guardians don't say that the token was burned? So a token can't be minted on the destination chain. Good questions. What happens to the original token if the guardians don't say that the token was burned? So if, let's say, so we have 19 guardians. These are 19 of the biggest staking providers in the space, which are all fully KYC'd, which brings some sort of like an additional security, because it's clear who these people are and who they are voting for, who these organizations are. But let's say there these 19 validators in some sort of way get corrupted, and they don't say that the token is burned, even though it is burned, then no minting would happen. So the token would be the token is burned, so you can't recover the burning easily because it was already burned on the source chain. But if the guardians say no, it was not, they don't verify that the token is actually burned, then the minting would not happen. So the token would be stuck in limbo, how we would call it. But you could then go ahead and add, since you have full control over the deployment, you could add a different GMP solution, like Axela, for example, which would then go ahead, verify this, and then trigger the mint function at the later stage. So it is possible to resume tokens that are in limbo for whatever reason. Yes, by afterwards kind of verifying that something happened on the source chain. Yes. So the attestation for the action on the source chain can be submitted at a later stage as well. This happens occasionally as well with, for example, stack transactions on Solana. So let's say you want to send a token from Base to Solana on mainnet, but there is some sort of issues on Solana, why transactions are not landing. Could be different issues, not enough priority fees, RPC issues, whatever. So you have the scenario where on Base the token is burned, but it was not minted yet because the transaction could not land yet on what do we say, Solana. So what would happen then is that you can go ahead and in a decentralized way just re-trigger the attestation by telling, in this scenario, the Wormhole Guardians, for example, or the used general message passing platform to attest to the function again. So the Guardian network, let's stick with this example, is where attestations are created, and you can just subscribe to it yourself. It's fully public, and you can check which guardians attested to which function, for example. So without even using Wormhole products, you can just spin up an RPC, or we created what we call a SPY for it, but in theory, you don't even need that. The SPY is like a dedicated solution that we built to subscribe to the Guardian network and see the created attestation, see which Guardian basically attested to which functions or actions in general, but you don't need that. You can just yourself just call the Guardian network and subscribe to it and see any action. And then also you can re-trigger an attestation to kind of double check something which did not happen before. So the token that's stuck in limbo can still be recovered because the burn still happened, right? So as long as someone can verify that the burn happens, your entity manager contract can then go ahead and say, cool, I've seen that in a verified way, the burn function was actually performed. Then the entity manager contract will go ahead and trigger the mint function on the destination chain to mint the token. I hope that was somewhat clear. Let me know if not. Let's see what other question we have. Suppose you deployed the Encode token from Solana to Base with the mint and burn mechanism. I suppose you'll have to write a new contract for it to operate, since one is SVM and the other is EVM. So do you you don't need any new contracts for the verifications, but I assume you're referring to token contracts. If you're referring to token contracts, then yes, of course. You need to deploy a token to any chain that you would want to have support with. Wormhole only enables you to transfer those tokens or let those tokens speak to each other in a decentralized verify and composable way. But the token deployment needs to happen by you. So let's again go over a flow. You deploy a token to Solana. This is your control. You deploy a token to Base. Then once you have 2 deployed tokens, you can use the entity framework to make them talk to each other. So you can transfer data, you can communicate any sort of data that you want, but the connection between them is what you would use Wormhole for. But the tokens themselves will need to be deployed by you. I hope that was the questions. Yes, otherwise it's just a token without any utility. Yeah, okay. So I assume that then this answered your question. Cool. I see, I understand the burn and mint model kind of, but hub and spoke less. Okay, let's talk about hub and spoke one more time. No problem. The main difference why people choose to use hub and spoke instead of burn and mint is because the token that they already have doesn't support the needed burn and mint functions. Because in order to use the burn and mint mechanism, your token needs to have a burn function, a mint function, and the possibility to actually set a token minter. Or on Solana, you need to move the token minting authority to the entity manager, actually. So let's say you have a token, you have a project, your token is already live, it's not upgradable, but you still want to use Wormhole entity framework in order to communicate or to transfer like your token to different chains. Then is when you would use the hub and spoke model as an example, because you don't need to modify your token at all because it only gets locked and unlocked in a custody account. For that, the token itself doesn't need to have any functions besides the possibility to being transferred. And any token has the possibility, I mean, not any token, Soulbound tokens don't, but like regular ERC20 tokens always have the possibility to be transferred somewhere on that respective chain. And this somewhere would be a custody account, and that's it. So your token would then be transferred again to this custody account on your hub chain. And the burning and minting of new tokens still stays the same on those spoke chains. The spoke chains are basically, again, burn and mint enabled chains where you deploy a new token, which will then obviously have a burning and minting functionality because since you deploy it yourself, now again, kind of new, you can choose the functions that you want. So I hope that clarified the difference between burn and mint, where you only have burning and minting, and hub and spoke, where you have locking and unlocking on a hub, and then again, burn and mint on spoke chains. Thank you, that makes sense. Okay, of course. Then I think there is no other questions for now in the chat. Let's continue with the presentation. The last thing before we actually finally start to look at code is what I want to mention is the flexible verification mechanism. I kind of already said some of those things during when I tried to answer your question, but let's again talk about these two very interesting points about what makes NTT flexible. The first one is that you don't have any sort of lock-in. So you can manage any additional verifiers and use any number of those. So with NTT, you're not bound to Wormhole attestation. Like I mentioned before, NTT is just a framework. So it's just kind of our way to propose how transfers should happen between chains, but it's not necessary for you to use Wormhole contracts at all with that. So you could, in theory, use NTT, and for verification, just use Axela as an example. What you could also do is the second point that we see on the slide is to specify M of N thresholds for verification. So, for example, what Lido did is they decided that they want to have additional security measures. So they're using Wormhole and Axela together. let's look at the next slide where we actually have more for that, more information around that, how it works. So what we see here is that we have one token on Ethereum, one token on BNB chain, manager, the entity manager deployed once on Ethereum and BNB chain. But what we see as well is that we have two transceivers. Transceivers is what we call the verification contracts that are deployed on each chain. The whole entity framework basically consists mostly out of these two contracts: the entity manager, which takes care of calling the right function and ensuring rate limits, and the transceiver, which is only responsible for actually verifying actions happen on the source chains to then trigger something on the destination chains. Sorry. So what we can see here is that we have two wormhole transceivers and two XLR transceivers. So for any message that's for any wrapped stake ETH token that gets transferred from Ethereum to BNB, Wormhole and XLR independently verify this action. For example, if we look at, if we think of a scenario of the previously mentioned burn and mint, then when wrapped stake ETH gets transferred from Ethereum to BNB, the entity manager calls the burn function. The token gets burned on Ethereum. What the wormhole transceiver and the XLR transceiver independently look at this and try to verify if that actually happened. If both transceivers say, yes, this sounds good, we can verify that burn function was actually successfully performed on Ethereum, then only and only then the entity manager can go ahead and call the mint function on the BNB chain to mint the token, which is pretty cool. It's kind of like the cool example of collaboration that we don't see that often in the space of kind of competing solutions, but to ensure that security is enhanced for critical products like wrapped stake ETH. Okay, I hope that was I hope that was understandable. That's also already the end of the demo, the end of the presentation, and time for actually demonstrating to you how to do that with our entity CLI. But let me know if you have questions before we move on to look at code finally and to deploying entity contracts. Let's see. Okay, I don't see no questions. So I hope that everything is sort of clear for now. Sorry. So, okay. Then let's go on to the second part of the presentation, where we are going to actually deploy entity. We have like 20 more minutes, should be fine. What we built to make this process easier is the entity CLI. So in theory, like I mentioned, all the contracts are open source and fully open source and verified and audited. So in theory, you don't need Wormhole to deploy anything. You don't need the entity CLI to deploy it. You can just go ahead, go to GitHub, and just deploy the tokens yourself manually. But if you don't want to, we built an entity CLI, which will make it as easy as possible for you in a couple of minutes to deploy the contracts that you want. Yes, with using the CLI instead of using the contracts manually. And my goal for today is actually to only use commands that we have inside our documentation, so it will be as easy as possible for you to go back and just copy and paste the commands for your respective tokens. So you would not, in theory, need to look at this video again, but just copy paste commands to deploy everything just based on our documentation. So you can go to our wormhole.com/docs. Let's actually do that from scratch. Then you could go and look at how to deploy the native token transfers. And then it should take you to this deployment page where you can see all the steps that we are going to perform now. As a prerequisite, which is important to mention, I already deployed a token, just a random token to Solana, and also a random token to Sequoia, just to speed up the process. Just a regular SVL token, a regular ERC20 token, which we will now connect. Let me just double check. You can see my terminal now, right? Somebody say yes, thumbs up or something. Yes, cool, thank you. Awesome. Just double checking. Sometimes it's only the browser that is seeable.
Cool. But could you zoom in a bit, Evgeni?
Yes,
on the terminal.
Good point. More, or is that enough?
One more time. Yeah, that looks good.
Yeah. Awesome.
Yeah, perfect.
Thank you, Rebecca.
Thank you.
Cool. All right. So let's continue. As I mentioned, I have two tokens deployed: a simple SVL token and a simple ERC20 token. So what we would do now is you would take this command to install entity, which I already also did, so we can check the entity version. Cool, that works. And then go ahead and actually deploy to EVM and to Solana. So inside the documentation, let me make it a bit bigger as well. Inside the documentation, you can see all the necessary requirements for the token deployment. Your token needs to have the mentioned burn and mint mechanism in order to use the burn and mint functions that we are going to do. But we also specified an example entity token here, which I actually also just deployed. So in theory, if you don't have a token and you just want to have a token that does burn and mint and that's it, then you could use this repository, clone it, and in the README here, you'll find the used, the forge commands which are needed to deploy the actual token. Well, what I also did. So you would go ahead and create and use forge create to deploy the token, and then mint yourself some tokens again using this cast command, and that's pretty much it. Afterwards, what we will need to do once we have the token is actually create an entity project to deploy entity. So let's go ahead and do that. Let's do entity new, encode entity token. So now we're creating our entity project. The next step will be to initialize our configuration file. So this deployment.json file is going to be our most important config file, which will have all the necessary information for the entire token deployment. So we can, let's go inside the repository and initialize testnet, since we want to deploy to Sequoia and Solana DevNet today. So now we should have a deployment.json, which is empty, which we are going to populate with the commands that we need in order to make those tokens basically talk to each other. So, all right, we created our project. We specified our configuration file. I set up my Ethereum private key before, and the only command that is left to perform on Sequoia for now is to actually specify which token we want to use in which mode. Let me get my token address and just verify that the deployment worked that I did before this workshop. See, an hour ago, I created this Encode entity token and minted a bit of supply, so now we can go ahead and just copy this token address and input it into this command that we see from the docs. So what we're going to do is say entity add chain. We want to add Sequoia. We want to use the latest contracts. Today we want to use it in burning mode, and the token that we actually want to use is this token, which is this encode entity token. and we want to skip verification on Etherscan just for the sake of time. All right. So while we've seen before that our config file, the deployment.json, is empty, ideally after adding Sequoia, it should have the deployed contracts to the entity manager and the transceiver to Sequoia. So let's see if this works. We are installing some dependencies and basically deploying the first contracts. See, we're deploying the manager. And afterwards, this is already almost it, what we need to do on the Sequoia side for now. So as the next step, what we would do is we would go ahead and deploy to Solana. While this is loading, compiling, let's look at the Solana section. Since we want to today move tokens between Sequoia and Solana just for testing purposes. So what I did before this, again, I already deployed the token for the sake of time. But if you don't know how to deploy an SPL token, we have all the steps in the docs as well. So you can just go ahead and copy paste all of those commands inside your terminal and create an easy, simple SPL token if you've never done that. Let's actually also double check that deploying this token worked for me an hour ago. Yes, we see that I have a token here with 100,000 supply. So that looks good. It's fine that the simulation failed because of a different EVM version. The deployment should still work. So what we see here is what is important. In the logs, we see that we are deploying an entity manager, and we have a transceiver address, and we are immediately setting this amount as an outbound limit, simply to have the outbound limit as big as possible, because we don't want to limit it right now. But I'm going to show you in a sec how to actually modify the rate limits. All right, so while we are waiting for the deployment, let's go back to the docs and see what we need to do for Solana. For Solana, we need like 2 more additional steps in comparison to Ethereum. We don't need to set up a new project because we already have an entity project with Sequoia added to it. We don't need to initialize the deployment because we already also did this for testnet. But what we need to do for Solana is to set the mint authority to the entity manager. On the EVM side, we also need to do that, but we can do that at the end to set the token minter to the entity manager. But for Solana, we are going to do it immediately because it's actually checked during the deployment. And in order to do that, we can again just go ahead and copy and paste those commands inside our terminal. Let's see, maybe there's RPC issues. It's still loading. While we are waiting for the Sequoia deployment, we can just in a different terminal window continue with our Solana part. Okay, now it worked. So what we see now is that the execution was completed and successful, and we added the Sequoia token to the deployment.json file. If you remember before this command, our deployment.json config file was empty, and now ideally it should have all the necessary contract addresses just in the same file. So let's look at it. And cool, this looks good. So what we can see now here is all the information that we need. We see that the network is testnet. So far, we just connected one chain, which is Sequoia, in burning mode with this manager contract, this token that we specified, and this transceiver address. We're going to adjust the limits after actually connecting Solana as well. So let's go ahead and do the Solana part. So for Solana, what we need to do first is to generate an entity program key pair, which let me check if I have enough Sol on DevNet. Okay, Dane. that looks good. We have enough so. So, right, let's generate the entity program key pair. You can, I mean, we called it entity, but this is optional. You can choose the name of your program key pair the way you want on Solana. As a next step, we need to derive the token authority. So we need to know which PDA of the previously created entity manager is actually the right one to set the SPL token mint authority to, because we need to know that for the next step where we actually will delegate minting control to the derived PDA. So let's actually do that and say entity Solana token authority. So we want to know the token authority of this newly created program key pair. And let's now go ahead and set the SPL token mint authority to this newly derived PDA. We need to do that in order to actually give minting permissions to the entity manager. So whenever, again, a token is sent from Sequoia, burned on Sequoia, and in order to be minted on Solana, the entity manager needs to have this token authority in order to perform the minting. Otherwise, no token could be minted on Solana with this way. Yeah. Cool. So in order to do that, we need the token address. So let's copy our token address. We want to say that we authorize the minting. So we specify the mint flag, and we need the PDA, the program derived address of our entity manager. Nice. So we updated our minting authority from my wallet that I use for the deployment to this PDA. So now the entity manager controls the token minting on Solana. And now we need, as a last step, or like not last step on Solana, but second to last step on Solana, we need to perform the add chain command as well. So if you remember, we did the same on the Sequoia side just a few minutes ago. Before we actually do that, let's take a look at our configuration file one more time. So we can see that for now, the specified chains include only Sequoia. And ideally, if our Solana DevNet deployment works out fine, then we should see Solana here as well. And then we know that we deployed the entity manager and transceiver to the Solana chain successfully as well. And the final step will be to actually cross-register both with each other, which you can also do with the CLI. Yes, so let's perform the add chain command. Let's actually just copy this over. So we say entity add chain. We want to add a new chain, Solana to Solana, use the latest contracts. We want to use, again, burning mode to have a full burn and mint mechanism between those two chains. And now we need to specify the token. Let's get the token address. We need to specify the payer, which I need to check. So I need to use my wallet for that. This is the key pair path to my currently used DevNet wallet. And then we need to specify the program key. So the program key is the entity manager key that we grinded a second ago. So this is this one. And that should be already it. Let's see if we did not forget anything. So it's compiling. This will take a second on Solana. So let's go ahead and look at the last step for the docs that we need to do. And it's the last step is to actually cross-register both chains with each other. So after deploying the needed contracts on each chain, we now will, first of all, optionally, but we will do that, configure inbound and outbound limits by specifying what the amount should be, what the amount of tokens should be that can move between chains on a 24-hour basis. And in the end, we are just going to push the final deployment once the rate limits are set to be ready to transfer the tokens between both chains. Okay, we have 8 more minutes, almost done. I think we can do that. What would simulation do? The simulation would just check with Ether. So Etherscan is doing the verification, and the simulation would just simulate the deployment itself. But in order to have a successful simulation, you need to have the same EVM version. And probably my local EVM version is different from the EVM version used for the token in this example. That's why it says that the simulation would have failed. But if you have the same EVM version, it should fine, and it would simulate the actual deployment. Okay, so Solana is still loading. Okay, so while Solana is still loading, I want to use the time and show you our Connect framework. So our Connect framework, you'll find it in the post-deployment section, is actually what you can do in order to test this deployment in the most easiest way. So after you deployed the tokens, cross-registered them with the CLI, what you want to do next, actually send tokens, right? And the two most easiest way to do it is actually by either using our TypeScript SDK or the Wormhole Connect product, which is a React widget, which makes it as easy as possible with a couple lines of code to just send tokens. You can connect your wallet and then send tokens between different chains. You can inside our documentation, we have a link to our GitHub where we created a repository which will make it as easy as possible for you to just plug and play your entity token. So all you need to do is clone this repository, which I already did. Okay, Solana's already done. So actually, okay, cool. Before cloning this repository and looking at Connect, which we'll be able to do that in the last 5 minutes, let's look at our deployment.json file to verify that we have Solana there as well. We do. So what we can do now in order to modify the rate limits is actually first do an entity pool. The entity pool command will populate the inbound limits with based on the connected chains. So what entity pool does is it looks on chain and checks. So we see here that we have no inbound limit, for example, but the entity pool command checks on chain which contract is actually deployed, which is registered with your entity manager. So which peer we have right now, and populates kind of our configuration file with the respective chain. So for Solana, we have Sequoia with no specified inbound amount yet, and for Sequoia, we have Solana. So right now, what this would mean is that 0 tokens can move on a 24-hour basis between those two chains, which we obviously do not want. We want to have to increase the limit to enable tokens to be transferable, which we can do directly in our deployment.json file. So let's just increase this number to, let's say, 10,000 for now. And finally do an entity push to push this limits on chain. Entity push, payer. And after this push, we are done. We made our previously 2 created token completely natively cross-chain transferable. So right now, this token can move between Sequoia to Solana by being burnt and minted until our specified threshold of the rate limit is reached. So 10,000 tokens can move between, can go ahead and move from Solana to Sequoia on a 24-hour basis in a burn and mint fashion. And that's it. So it took us, with all the explaining, roughly 20 minutes, maybe 25 minutes. So you can see that it's pretty quick to do this with the CLI, which is pretty cool. And the last step, which I want to mention, is the how to even like in 2 minutes create your create a front end, create the UI where you can connect your wallet and actually transfer the tokens. Let's see if we can push this quickly on chain. Cool. So this is done. The deployment.json says that our limits are now increased. We can check with entity status that everything looks fine, and we actually have peer registered chains with each other. Otherwise, entity status would like complain that something doesn't look right. And so, as I said, as a final step, I already cloned this repository. Let's go into the connect repository and make our tokens transferable. For the sake of time, I'm not gonna actually input the values here, but the last thing that you would do is actually just copy the deployment.json file. I mean, this is what I usually do. You can copy it inside your project. And just input all the values that you need in this file here, and that's it. So the last step to actually make it transferable would be to copy the manager address and input it into this app.tsx file and change the networks to the ones that you need, and you're done. So after doing all the copy and pasting, you are ready to use the front end to transfer the tokens. And it looks like this. This is the front end. You can connect your wallet out of the box and do transfers. These are the tokens that I created before. But this will, the Encode entity token would also appear here if you would like actually go ahead and specify the needed contracts in our configuration file here. And that's it. And then you would be able to immediately send tokens from one chain to the other chain. And you have full Wallet Connect support, and that's it. So super quick and fast way to spin up a UI and be actually ready to transfer your token for any sort of chains that you want. Yes, right on time, I guess. Cool, let's see if we have any questions in the chat.